Kohlrausch law of independent migration of ions. Kohlrausch was able to establish a constant for the differences of molar conductivity at infinite dilution of potassium fluoride minus molar conductivity at infinite dilution of sodium chloride. In fact, you have got various salts here. What is this? KCl. Here, NaCl. So it is the difference between the molar conductivity values at infinite dilution between KCl and NaCl, right? What about here? KBr and NaBr. Here, Ki and NaI. Now listen, these values are always constant and that is 23.4 psi mol. Then square centimeter per mole. Now listen, from this we are able to understand that these values are almost independent of migration of certain ions. For example, in this case, KCl is associated, right? But it is the difference between KCl and NaCl. K is predominant, Na is predominant. Do you understand? There. In this case, the same potassium salt and sodium salt, but the anions are different. Okay. Similarly, here also potassium iodide, sodium iodide, but the focus is potassium and sodium only. It means it is independent of these ions associated, their differences are always constant. This is called, what is that? Kohlrausch law of independent migration of ions. Are you able to follow? So it means the limiting molar conductivity of an electrolyte can be represented as the sum of individual contributions. So this law can be interpreted in another way as I'll introduce a simple equation. For example, I have, so this is called ionic conductance. When I put small, lambda, this is ionic conductance and this is the electrolyte conductance. This is ionic conductance. Okay. When I put lambda at infinite dilution of Na plus, what is this? Ionic conductance of sodium cation. Okay. Right. And ionic conductance of chloride anions. Okay. Got it? Now, sodium chloride, its equivalent conductance or molar conductance. You can represent this as equivalent or molar. So I am considering here molar conductance. So the molar conductance, that is molar conductivity. So the molar conductivity at infinite dilution of NaCl is the sum of, what is that? The sum of participating ionic conductance. Okay. Participating ions conductivity values. It means lambda not m NaCl is equal to delta, small letter delta not Na plus lambda not of Cl minus. So it is the sum. Now you please go through that. This law states that the limiting molar conductivity of an electrolyte. What is that limiting molar conductivity of electrolyte? That is represented by delta M, capital letter delta M of NaCl. This is the electrolyte. This is represented as the sum of the addition of the individual contributions of what? Cation and anion. Are you able to follow? Okay, that's it. So, what is the Kohlrausch law of independent migration of ions? This is nothing but the limiting molar means at infinite dilution. Okay. So the limiting molar conductivity of an electrolyte, in this case NaCl, is equal to the sum of ionic molar conductivities of the participating ions like Na plus and Cl minus. That's okay. So you just make it as an equation, and based on that, you can easily define. Okay. And if we want to generalize, we can do it. How? For example, take down. I am taking any molecule, any electrolyte. So any electrolyte. What is that? The limiting value of, tell me, the limiting value of molar conductivity of an electrolyte. This part is electrolyte is equal to, and we know, for example, V plus means that much number of cation into lambda plus of naught plus that much amount of anion into lambda minus naught. Okay. For example, if it is um, say that is if you have got a CaBr2 or CaCl2, in that case, calcium is plus 2 plus. So you can put only 2 plus here, but its values are here minus 2, is it not? So 2 minus are there. So 2 into Cl minus. Likewise, you have to put. Okay. Now let us work out some values so that we will be able to understand. And based on that, there is another concept called that is according to Arrhenius concept. Take down lambda at a certain concentration. That is lambda m. What is that? Lambda m. Molar conductivity of an electrolyte at certain concentration divided by its limiting value. Limiting value means not is equal to alpha, that is degree of dissociation. This is another important equation. So alpha m divided by alpha not m is degree of dissociation, not alpha, lambda. Lambda m divided by lambda not m is equal to alpha. Alpha is degree of dissociation. And we have got another equation called Oswald's dilution law. This we have already discussed under ionic equilibrium. Oswald's dilution law. According to this, Ka is equal to, that is C alpha squared divided by 1 minus alpha. Okay, C alpha squared divided by 1 minus alpha. I will show you how to derive the ODL also. It is better to learn at least in this stage. Take down ODL derivation. Let me consider any acid HA that gives H plus plus A minus, right? So initially, initial number of moles, let us say, initial number of moles 1. During T seconds, okay, during T seconds, the number of moles decomposed is alpha during T seconds. Now, after T seconds, what is that? After T seconds, the remaining number of moles is 1 minus alpha. And what about here? Alpha is split. Alpha amount is split. What is alpha? That is the degree of dissociation. That is number of moles dissociated divided by total number of moles. What is alpha? Alpha, write down. Alpha is equal to degree of dissociation. That is nothing but, write down, number of moles dissociated divided by total number of moles. So being the strong electrolyte, completely it is dissociated. Suppose if it is a weak electrolyte, only part quantity is dissociated. It means alpha is less than 1. So for strong electrolyte, alpha is equal to 1. For weak electrolyte, alpha is always less than 1. Do you understand? It means they do not undergo dissociation completely. Why? Because of its weakness. Now, so this is the 1 minus alpha, alpha. And let us calculate the concentration. So what is the remaining concentration? The remaining concentration So again, simply multiply by C so that you will have the concentration C into 1 minus alpha, and this is C alpha, and this is C alpha, right? Now, according to equilibrium constant, Kc is equal to, what is that? The product of the concentration of the product divided by the product of the concentration of the reactant. So H plus concentration into A minus concentration divided by HA. Got it? Now you can substitute because we have got already this concentration value. Okay, this represents the square bracket value concentration. So this is C alpha, C alpha. So C alpha into C alpha. Is it not? C alpha into C alpha whole divided by, what is the value of this one? C into 1 minus alpha. So C can be cancelled. That is why C alpha squared divided by 1 minus alpha. So this is called ODL, Oswald's dilution law. Okay. Now we already know alpha is equal to what? Delta, lambda m divided by lambda naught m. Okay. This is alpha. Now we can substitute this alpha by this value. Got this? Therefore, now let us substitute. So Kc is equal to C into, what is alpha? Alpha squared. Alpha is nothing but this much. So lambda m divided by lambda naught m the square into 1 divided by 1 minus, okay, again alpha, that is lambda m divided by lambda naught m. Are you able to follow? Let us take the LCM. So C into Kc is equal to C into, what is that? Lambda squared m divided by lambda naught squared m into, and what is that? 1 divided by lambda naught m minus lambda m divided by lambda naught m. So you can reciprocate and cancel. So C into lambda squared m divided by lambda naught m squared into lambda naught m divided by lambda naught m minus lambda m. So you can cancel this. So you are able to get lambda squared m divided by lambda naught m into 1 divided by lambda naught m minus lambda m. This is Kc. Okay. And applying Kohlrausch law, we can determine the unknown values of ionic conductance or molar conductivity. Ionic conductivity or molar conductivity. Let us discuss a few examples here. Take down. Calculate. These are all the applications of Kohlrausch. Calculate lambda naught m problem for calcium chloride and magnesium sulfate. These are asked. The data are given in the table. So they are given the values of, that is ionic conductance at infinite dilution, that is limiting ionic conductivity of, they are given the calcium value as 119.0 Simon centimeter square per mole. Then chlorine value is equal to 152.6 Simon, etc. And then you have the value of magnesium ion, that is Mg2 plus. Its value is found to be 106. And then sulfate SO4 2 minus. So that is equal to 160. Okay, so based on that, you should be able to find out. We have got already the law. What is that? Let us find out the first one. Delta M, according to Kohlrausch law of CaCl2, should be the sum of what? The respective ions. Is that not? So in that case, I think this is not 152. This is 76.3. Okay, 76.3. Right. Now, according to this, now lambda not M CaCl2 is nothing but ionic conductance of Ca2 plus, and there are two chloride. So 2 into lambda of Cl minus at infinite value. So in that case, what is Ca2 plus 119 plus 2 into, because CaCl2, so 76 into 76.3. So therefore 119.0 plus, and this is 152.6. Now you can add these values so that you are able to get 6, 1, 7, 271. Okay, so 271.6 Simon square centimeter per mole for lambda CaCl2 at infinite dilution. So this is answer. So similarly, you have to find out for Mg and SO4. For MgSO4, actually it is 1:1 ratio. So you can put simply Mg value add with SO4 value. That's it. Okay. I hope you can do this some very easily. So 266. Right. So similarly, you can try other applications of Kohlrausch based problems. And finally, that is we'll be discussing about the um, batteries. Okay. So let us discuss in the next class.